Good morning, good afternoon, and good evening, everyone, wherever you might be joining us from. Today, we're excited to talk to you about our ultra-low power asset tracking solutions featuring Semtech, AWS, and TEKTELIC. Next slide, please. So today we have a lineup of 3 speakers. So I'll begin by introducing myself. My name is Karthik Ranjan, and I'm Partnerships and Solutions Leader here at Semtech, responsible for working with our ecosystem partners, such as AWS and TEKTELIC, on cloud-based solutions. I'll turn it over to Max to introduce himself.
All right, thanks, Karthik. Hey, everyone, my name is Max, and I'm Product Manager from AWS Saudi Core Device Location. Excited to be here with you today, eager to share the excited insights and detail about our asset tracking solution and offerings, and looking forward for to have an engaged discussion with you.
Yeah, and hello everybody. My name is Jack Stewart, and I'm a Business Development Director and Product Line Manager at TEKTELIC. I'd just like to thank Semtech and AWS for including TEKTELIC in this event. I look forward to providing some insights on how all of us are working together to solve a real problem with practical low-power asset tracking solutions. So thank you, Karthik. Thank you, Max. Look forward to this event.
Excellent. Thank you, Max and Jack. So we have a couple topics to cover in the agenda today. So we'll begin by talking about Semtech's LoRa Edge and LoRa Cloud. We will then jump over and talk about AWS and our LoRa Cloud solutions. And then we'll have Jack talk about TEKTELIC's asset trackers, which they're coming out with, which you can actually use together with the AWS and the LoRa Cloud solutions that we'll talk about during the webinar today. And finally, we will end with a Q&A. You should have a question box inside your user interface. So as we are speaking, feel free to enter in your questions, and we will take time at the end of the presentation to review the questions and try to answer as many of them as we can. So without further ado, let's get started. All right, so let's begin by taking a look at the market forecast for LoRa. So this is data from IoT Analytics, which shows a 43% CAGR between 2019 and 2025, with the total number of LoRa shipments exceeding over 1 billion by 2025. And as you can see from the table on the right, this is across a variety of different verticals, such as healthcare, home and consumer, retail, and you see the estimated CAGR in each of those areas. One of the biggest use cases that we see across all of these verticals where LoRa is adopted is the need to be able to track these assets and have geolocation, whether it's wheelchairs in a hospital, your pet at home, shopping cart, golf carts, or high-value assets inside an industrial setting, or even things like tracking your cattle in the field. Asset tracking is by far the most popular use case that we see in each of these verticals where LoRa gets deployed. And one of the challenges has been with existing solutions today using on-device GNSS, power consumption is very important. In LPWAN deployments, one of the biggest costs to OpEx is the need to go out and change batteries or recharge devices in the field, which can add significant cost to the overall operating expenditure for an IoT deployment. Next slide. So in order to solve the problem, Semtech came up with the LoRa Edge and LoRa Cloud-based solution. So what is the solution? As many of you may be aware, Semtech creates transceivers for LoRa. These are essentially the transmit and receive radios, which go into many of the LoRa devices that cover those industry verticals that you saw previously. With LoRa Edge, Semtech added on top of the transceiver several features which make it really easy and optimized to use for asset tracking applications. The first part of it, in addition to the LoRa radio, is being able to add GNSS scan and Wi-Fi scan. Now, this is not a full GNSS on-device receiver on it. It's basically waking up. It's being seeded with a course location and an almanac, and it wakes up and it's able to scan the sky and receive timing information from specific satellites. That data is then pushed to the cloud, and the cloud then does the heavy lifting of being able to solve the latitude and longitude. However, not all devices in IoT have a clear view of the sky. Sometimes they're indoors. For example, in end-to-end supply chain, a device might be on a truck where it can see the sky, but then that same device might go into a warehouse where it doesn't. Fortunately, inside the LoRa Edge product, we have added Wi-Fi scan. Now, Wi-Fi scan is not a Wi-Fi radio. It essentially scans the MAC addresses of the known SSIDs that are in the region where the device is located. And then again, it pushes that Wi-Fi SSID scan information to the cloud, which then is able to return a latitude and longitude, giving you visibility of your product, whether it's indoors or outdoors. And then finally, Semtech has also integrated hardware, crypto, and key store into the LoRa Edge devices, removing the need for OEM factory provisioning. Historically, LoRa devices, the keys were injected within the factory, and the manufacturer who has done that typically provides that to the OEM who provides it to the end customer. This risks key material being available throughout the supply chain without a chain of custody of those keys. And so by provisioning them into the chip itself, customers can be able to extract those keys at the time of deployment, increasing the level of security. And of course, the LoRa radio itself, which is inside the LoRa Edge, is the best yet in terms of performance, giving the longest range and best battery life. So what does this sum up to be? It means you as a customer get 10% lower or 10 times lower power consumption than a traditional on-device GNSS solution. And you also save approximately 43% in TCO in the whole hardware BOM because you don't have discrete chips around your MCU to be able to do all of these functions. Next slide, please. So let's dive a little bit deeper into how the cloud-based resolution works. So there's two distinct components to LoRa Cloud, which are actually part of the AWS IoT device location feature, which Max will talk to you about. So on the GNSS side, we have satellite data that we receive for both GNSS in USA and Europe and Beidou, which is available in China. We also receive atomic clock information that we then pass down to the device to be able to have synchronization with the atomic clock. The LoRa Cloud also provides almanac updates, either full or partial, depending upon if the device is already shipped with an almanac, to be able to update and ensure that you have a fresh almanac on the device at all times. And this solver then supports 2D and 3D Earth-centric, Earth-first position solving, giving you a latitude and longitude for where your device is, no matter where it is outdoors. On the right side is the Wi-Fi solver. Now, the way Wi-Fi solvers work is you have a database that gets continuously updated with Wi-Fi SSIDs corresponding to latitude and longitude. Now, this is done via a variety of different data sources, such as cars, phones, tablets, PCs, and other devices, which have both GNSS and Wi-Fi to create such a database. And then accuracy is constantly being improved based on new data that's received into the database. So as you see, the device will send up the SSIDs, and then the cloud solver will then return the latitude and longitude. This is how we're able to obtain location data within the LoRa Cloud environment. Next slide, please. So what we did was actually did a real world test with 2 months of simultaneous use with fresh batteries in 2 devices. So we took a traditional LoRaWAN based on-device GNSS tracker, which is the first one on the list that you see there. And then we took the Semtech LR1110 based reference tracker, and we put them both to a test for 2 months. And what you see is that the on-device GNSS tracker used about 14.4% of the battery to solve 576 location points versus the LR1110 LoRa Edge-based design, which only took about 5.1% of battery to deliver 661 data points. So this is real-world data based on an actual use case that was conducted last year. Next slide, please. So what are the use cases where you can actually utilize this? So what you see here on the graph is the y-axis that shows the battery life, and the x-axis the number of updates that you need. So things like fast sports, people tracking require very frequent updates, which may not be the most optimal use case for LoRa Edge to LoRa Cloud. However, there's a number of different use cases that require updates maybe once an hour or once every couple days. And those are things like industrial track and trace, where something might sit in a warehouse for several weeks or months where you don't really need an update if the device isn't moving. Things like shared bicycle tracking that, again, may have movement during the day, but may be dormant at night. Cold chain monitoring, the ability to be able to track things all the way from manufacturing, all the way when they are at retail, and knowing where they are indoors as well as when they're outdoors. And then finally, cattle tracking as well, which is very popular, which saves ranchers countless hours in being able to retrace their animals within a field. Next slide, please. So we've talked to you about this. Now, how can you actually try it? We're pleased to announce that we have a tool called LoRa Cloud Locator, where you can actually try this all for yourself. So you can come on to this, and the URL is there at the bottom. You can select from a number of different compatible trackers, and here we've included a variety of LoRa Edge trackers, but we also have an on-device GNSS tracker that you can purchase there and run the test for yourself side by side. We've also implemented a number of public, carrier grade, and community networks to be able to try it if you don't want to deploy a gateway. Networks such as Helium, EveryNet, Senet, which are all available in North America. And then in Europe, we also have Swisscom and Orange and others that are available for you to try it. And you can also deploy your own gateway as well with a private network depending upon your deployment scenario that you have. The tool enables you to see your battery life, like I showed in the previous slide, how much battery was used. So if you put in a fresh set of batteries and you run the test, you could recreate what we have on the previous slide. The service itself works very well on both PC as well as mobile interfaces. So as you're moving around and doing your testing, you can take your phone with you and access your dot on the map just like you would in front of your PC. So you can try it out today. The URL's at the bottom. Next slide, please. All right, so with that, I will turn it over to Max from AWS to talk about their AWS IoT Core device location service. Over to you, Max.
All right, thanks, Karthik, and hello, everyone. This is Max again, product manager on AWS IoT Core, and excited to be here to introducing our device location feature with you all. So let's get started. So what is IoT Core device location? So AWS IoT Core device location is a new service that we launched in reInvent last year, which is in November. And the key value of this feature is to enable our customers to obtain the IoT device location without a need of built-ins or on-device GNSS hardware. And as we know today, GPS is the most popular and go-to technologies for the location-based solution. However, many IoT devices does not have the GPS capability, mainly due to the higher power consumptions, large size, and higher the cost. So alternative location technology like Cloud Assist GNSS solution from Semtech has become more and more popular. And IoT Core device location, we integrated with multiple Cloud Assist geolocation solver, enabling our customers to use the Cloud Assist GNSS, Wi-Fi scan, cellular triangulations, and reverse IP lookup technique to determine the device geo coordinates, which is latitude and longitude. And in conjunction with our new location action from the IoT Core rule engines, customers now can easily forward the resolved location data to Amazon Location Service, where then customers can access to the map, point of interest, historical location, and geofencing functions. So in short, the IoT Core device location features, with it, customers can leverage and use our most advanced cloud-based geolocation technology to build the cost-effective and scalable asset management solution with us. All right, and let's take a look of the integrations before and after. Before we launch these device location features, can customers implement and build a like cloud location function with us? The answer is yes. However, it's much more complicated to do, right? Here you can see from the diagrams, we use the Semtech LoRa Cloud location solver as an example. In the past, customers first have to create an account with the Semtech, and then integrating the given tokens or URL into AWS Lambda functions to call the Semtech location solver. And after that, they also have to configure their IoT devices or trackers to send the location measurement data to IoT Core, and then to Lambda, and then to LoRa Cloud to resolve the location. And that's not it, right? Customers also have to use Lambda again to route the resolved location data to the downstream AWS services or their own application server. And the main issue here with this approach is not only that we'll incur additional costs from Lambda usage, and also customers have to write and implement their own coding for Lambda functions, and creating and managing multiple contract buildings with the different cloud server solution partners, which could be quite a bit of hassles for customer to do for this implementation. Next slide, please. And as customer asks us, like, hey, what's the better way to provide this location service for the IoT devices? We deliver this new native integrated multi-cloud server device location feature. And with this integration, as you can see from the diagram, the entire flow is much simplified. IoT Core device location now is working seamlessly with Semtech LI 1110 and 1120 trackers. So you can easily configure compatible trackers without any custom firmware needed to scan and send the GNSS and Wi-Fi measurement data direct to IoT Core device location. And once we receive the measurement data, we will then select the appropriate cloud location solvers and obtain the geo coordinates for you. And once again, the location is resolved, you can use either our rule engine location action functions to forward the location data to Amazon Location Services or to any of your desired destination. So this integration not only streamlines your overall customer experience compared to the previous non-integrated solutions, but also removing the need for you to write or implement any codes. So enhancing the overall accessibilities and ease of use for this function. Next slide, please. And for those who don't have your own applications, right, server, you can easily ingest location data to Amazon Location Service. And from there, you can visualizing location information on a map. You can also retrieve the current and historical location for your devices, determine travel time, destinations, or direction between the points. And most popularly, can creating geofence and detect when the asset enter the boundaries. So combine this device location and an Amazon location service, it provides a powerful tools in the AWS suite and enhancing this and providing a end-to-end location-based solution for all of our customers. Next one, please. So what's the benefit again to build the location-based solution with us, with AWS? Our device location features enable customers to create a full-scale asset management tools within the AWS. We provide centralized account management and a unified development platform. With multiple cloud server integration, our solution can provide a comprehensive location coverage for both indoor and outdoor usage, which can help you to transforming the way building and deploying the location-based application. And beyond this efficiency, our approach is also focusing on 3 core pillars. First one is accessibility. Our solution, again, is deeply integrated with Semtech LI 1110 and 1120. And on top, we also support the latest LoRa Cloud 1.6 version, which can support even better power saving and higher location accuracy. And you also remove the need for you to implementing additional code for any feature enablements. So this simplified the overall deployment process and let you focusing on the strategic objectives for your business. And next one is the scalability. Device location is built on the AWS, which is designed to scale accommodating businesses for all sizes, from startup to enterprise. And the last one is cost effectiveness. Our pricing model follows a pay-as-you-go structures, which allows you to only pay for the features and services you actually use. This also eliminates the burdens of substantial upfront investments and providing you the financial flexibility to scale your operations down the road. And currently, we offer tracker devices from the industry leaders like Semtech and TEKTELIC. We also anticipate to see more additional GNSS trackers rolling out from our partners in Q4, as we also understanding how difficult to choose the right trackers devices for the right solution. And to further facilitate this device selection process for our customers, we will be introducing the device qualification programs to all of the AWS partners to qualify the compatible trackers. And with these programs, we'll provide you a curated list of tracker devices that has been seamlessly tested and integrated with the AWS device locations, and later will be listed on our device catalog. So this will make it easier for you to choose the right trackers for your specific asset management needs. So again, we, AWS, will help you to migrate, modernize your location-based solution and meet your business goal faster. Next slide, please. And here are some additional resources for your reference. And from here, you can access to our latest blog post, developer guides, and workshop that we did last year in reInvent for more product details. All right, and thank you. And next, I will hand over to Jack from TEKTELIC.
All right, thank you, Max. Hello, everybody. As mentioned, my name is Jack Stewart, and I'm a Business Development Director at TEKTELIC. I'm delighted to join this webinar today to discuss how TEKTELIC is supporting Semtech, AWS, and the LoRaWAN ecosystem as a whole to solve real challenges in the asset tracking space with practical, reliable devices built on the Semtech LoRa Edge platform that Karthik introduced you to, and of course, seamlessly integrated with LoRa Cloud and AWS location services. So before we dive into the devices, I'd just like to provide a brief introduction to TEKTELIC and specifically our key areas of focus for providing value to the IoT ecosystem. So first of all, TEKTELIC prides itself on developing IoT products and solutions designed for the best performance and lowest deployment and operating costs. Simplicity, reliability, and scalability is key whenever we're designing products and solutions like the ones that I'll introduce you to here in a moment. And these goals, of course, are shared by Semtech and AWS, which is one of the reasons why we're so excited to be part of this initiative. TEKTELIC's IoT solutions are designed to be simple yet powerful, as we aim to tackle real-world challenges across 3 different vertical areas. So asset tracking, which is, of course, the focus here today, smart buildings or facility management, and digital medicine as well. And of course, at the heart of our success is a commitment to provide exceptional engineering, customer support, and expert guidance as we empower our customers to successfully deploy, manage, and maintain solutions for their unique use cases and deployment challenges. We can jump to the next slide. So, as we're all aware, IoT-based asset tracking solutions are transforming the way that we manage and monitor our valuable assets. In the past, keeping tabs on assets was often a very manual exercise, which can be very time-consuming, expensive, unreliable, inefficient. But the emergence of IoT-based asset tracking solutions is really changing this. And earlier in the presentation, Karthik showed some statistics about the exciting growth of LoRa-based asset tracking solutions. And as we can see here, the market size for IoT-based asset tracking solutions in general is already a multi-billion-dollar business, but it's projected to double by the end of this decade. So there's a very big opportunity. I mean, if you think about it, supply chains are more efficient than ever. Businesses can track their fleets of vehicles to ensure timely deliveries, reduce fuel costs. Construction companies can monitor heavy machinery, preventing breakdowns and downtime. Healthcare institutions can keep track of critical medical equipment, ensuring that they're always ready and available when needed. And with the advancement of sensors, devices, connectivity, and data analytics in this space, like the solutions that you're seeing here today, we're really on the cusp of more incredible innovation. And we can move to the next slide. So where's the opportunity? What problems and challenges, or what are the problems and challenges that TEKTELIC, Semtech, AWS, and other ecosystem players are trying to solve? Well, I mean, for one, the solution that we're looking to address is the often tricky challenge of both locating and monitoring the conditions of valuable assets, both indoors and outdoors, and as they move between indoor and outdoor locations. And also assets that are in transit between two physical locations. So this includes not only understanding their location, but understanding their movement activity, maybe the environmental conditions that they've been subjected to, whether or not the assets have been opened, damaged, dropped, those sorts of things. We've also aimed to build a solution that leverages as much existing networking infrastructure as possible. So things like Bluetooth, Wi-Fi, and GPS. What this does is it allows for speedy adoption, simple, scalable deployment, as really the goal here is to build a high-value solution without completely reinventing the wheel. And as I mentioned, asset tracking is really about much more than just locating your assets, but also understanding their movement patterns, receiving alerts and notifications about, entrance, exit events based on geofences, understanding different handling and environmental conditions that they've been exposed to. We're all looking to provide a solution that's accessible, meaning that the upfront hardware costs are low, devices can be used for multiple purposes, and the solution just works out of the box, meaning that it can be deployed, managed, maintained by anybody, regardless of their level of technical expertise or experience with IoT networks. And then, of course, a high-value asset tracking solution must be reliable and require minimal maintenance, meaning battery life is key. So the goal should be that a rechargeable tracking device can last for many months. 6+ months is typically the target on a single charge, and single-use battery, replaceable battery should last for 5+ years before battery replacement is needed. Okay, we can jump to the next one. Okay, so you've heard from Semtech about LoRa Cloud and how it's being utilized to provide a solution that addresses all of the challenges that we've just described. You've heard from AWS regarding IoT Core and Amazon Location Service and how these tools are simplifying one's ability to visualize and manage the tracking of their assets. So now we at TEKTELIC would like to speak to you a little bit about the devices that we've designed to meet these requirements as well. The first device that I would like to introduce is our new Stork tracker, and I'm holding one here. You can kind of get the sense of how it looks, the size of it, and sort of the form factor there. The Stork device is built on the Semtech LoRa Edge platform that Karthik introduced you to, and it's designed to locate, track, and manage assets indoors using Wi-Fi scanning and BLE, and outdoors using Semtech's low-power GNSS. Of course, all of the data flows into the network and into LoRa Cloud over LoRaWAN, and TEKTELIC has specifically designed this device to be rugged, as it's intended to be exposed to any environmental conditions, simple to attach and remove from any object, with multiple very practical mounting options offered. Taking advantage of the low power capabilities both of LoRaWAN and the low power GNSS offered by the Semtech LR1110 LoRa Edge chip, we can achieve battery life of over 5 years with this device. So it greatly reduces any required maintenance and logistical complexities and costs associated with having to keep devices charged or constantly replace batteries. There's many different applications where Stork will provide immense value, including equipment yards, warehouses, storage facilities, manufacturing facilities, assets in transit such as shipped pallets or containers, mobile equipment. The rugged IP67 design of Stork ensures that the device is operable virtually anywhere and will be providing high value, accurate, and reliable location and activity information about whatever asset's being tracked. So that's our new Stork sensor there. And then we can move on to the next slide. So the next one is our Chickadee device that we hear. So this is our next device that we've recently designed called the Chickadee. Just like the Stork, the Chickadee utilizes Wi-Fi, BLE, low power GNSS, as well as traditional GPS to provide very accurate, reliable tracking and monitoring both indoors and outdoors. And Chickadee is designed in sort of a wearable badge form factor that you can see here, so it can easily be clipped to a belt, lanyard, worn in a pocket. Really, the goal of Chickadee is to enhance the safety of workers, gain insights into their location and movement patterns, activity, and even things like conformance to corporate rules and regulations, those sorts of things. The Chickadee device, combined with AWS location service, accommodates geofencing to allow for entrance and exit notifications if there are certain areas where an employee activity needs to be monitored. It also includes an event button, which can be configured as an SOS or check-in button as well. And Chickadee actually comes with a rechargeable battery, but the battery life is still 6 months. So again, this greatly reduces the logistical complexity of ensuring the battery is constantly charged and minimizes the risk of a missed tracking event or a missed event due to a dead battery. So Chickadee really is ideal for locations like hospitals, warehouses, outdoor work sites, anywhere where you will have many workers present, like construction sites, energy production operations, commercial farms, those sorts of places. Okay, we can move to the next one. So in summary, the streamlined innovation that we're seeing with the complete end-to-end integration that you can see here of LoRa Cloud, AWS IoT Core and device location, and then of course supporting asset tracking devices from TEKTELIC and others in the LoRaWAN ecosystem is really making it easier than ever for enterprises to implement, visualize, and manage their most valuable assets. And not only has this process been simplified, but the supporting technology is accommodating scalable deployment, power efficiency, and reliable, accurate positioning. So as soon as this webinar is over, I'd encourage everyone to head over to TEKTELIC's LinkedIn page. We've actually just posted a short video which quickly shows sort of the true value of the end-to-end solution that all of us have presented for you here today. As soon as I'm finished speaking, I'll also throw a link to that video in the chat so you can follow that link. And yeah, just take a look and see what the whole solution is all about. That's it for me. Thank you everybody for your time.
Before we jump into Q&A, I just wanted to share this slide. We heard from TEKTELIC on their trackers, but there's a whole slew of trackers for a variety of different use cases. There's the vehicle equipment trackers like the Chickadee and Stork, which Jack talked to you about. There's several smart badges that are available for tracking and emergency alerting. There's also some cattle trackers. We talked about that use case for tracking your livestock in the field. And then there's a bunch of general purpose trackers which are available as well. And then finally, there's a slew of zero carbon trackers which use energy harvesting, which are batteryless, to be able to make sure that you don't have to change the battery at all. So lots of innovation that's coming in this. As Max mentioned to you earlier, AWS is going to be launching in their device catalog and solution finder these trackers which are compatible. So when that launches later this year, you will be able to go in and see all the devices which can work with the AWS device location service. So with that, we'll conclude the presentation and we can now move to the Q&A. I will share that in addition to myself, Max, and Jack, we also have some technical counterparts from Semtech, AWS, and TEKTELIC who can help answer some of these questions as well. So at this stage, I will jump over to the Q&A and let me jump to the question list. So here we have the first question. How do I know that my LoRa device or module is compatible with this type of location service? As I just mentioned, AWS will be launching their device catalog and solution finder later this year, and you will be able to go on the site and be able to filter by AWS device location and see a list of devices that are compatible with the service. I'll move to the next question. Amazon location service also include indoor location tracking. I'll give this one over to Gaurav Gupta from AWS.
Yeah, thanks, Karthik. Hi, everyone. Gaurav Gupta, part of the AWS, and I'm a principal solutions architect. Happy to answer that question. So Amazon location service will allow you to give a map, and in order to do indoor tracking, like especially if it is, let's say, Wi-Fi, you can use an overlay on top of the map. So you can zoom in and it can provide the overlay. The question is around an internal map. We have something in the plan where, or maybe something we are looking from customer feedback, which will allow customers to add the map internally, like internal building map, and using some BLE, we can provide an indoor map. So currently we don't support that. But as far as the measurement data is concerned, Wi-Fi, which can give a location for an indoor, or cellular, which can also correspond to an indoor location. In that case, you can use Amazon. You can use an Amazon location service and put an overlay on top of the map.
All right, very good. Thank you, Gaurav. Don't go far away because there is another question for you here. Actually, I don't see that. Oh yes, the next question. Is it possible to pipe data from a third-party provider of LoRaWAN network server to AWS IoT Core for location solving?
Yeah, that's a good question. Thanks for asking that. So in this case, it is possible to use one of the integrations that AWS has done. IoT has done with Actility, things in industries and OrbDevice, where the tracker that is configured in one of the LoRaWAN networks there can connect to AWS IoT Core, and this data can be used by Amazon location service. The only difference at this moment is the customers will not be able to utilize the native decoder that we have with AWS IoT Core for LoRaWAN. So in that case, the customer who are using a third-party LNS, they will still be able to use device location, but they have to write their own Lambda code to do the decoding and to call the get position estimate API to get the location. In short, it will still work, but there will be some extra code needed by the developer.
Okay, thank you, Gaurav. So the next question, is it correct that only devices that have LR1110 built in will be able to take advantage of precise location tracking? So I'll begin by answering it and then maybe turn it over to Max. So in terms of what Semtech talked about, we are focused on the LoRa Edge series. So it's LR1110 and LR1120 that have the GNSS and Wi-Fi scan capability that's compatible with the AWS IoT device location service. Now, the device location service, it does have a standalone Wi-Fi as well as cellular. So it is possible to use other types of devices that may not have LR1110, such as a cellular device. If you can pass it the right cellular data, the cell IDs, then you can use the cellular solver. Or if you have a different standalone Wi-Fi radio, it is possible to use the Wi-Fi solver. But the GNSS solver does require LoRa Edge devices. Max, do you have anything to add to that?
No, thanks, Karthik. Yeah, that's precise answers. Yeah, we do also support IP reverse lookup. However, the accuracy it's not as good as other three solvers. But again, if you don't have your 1110, but your IoT devices do have capability of doing the cellular tower scanning or Wi-Fi scan, then you can still use our cloud solvers to get estimate locations for the device. Yeah.
Thank you. All right, so the next question here is for Roman from TEKTELIC. I know that in first world countries, you have public LoRaWAN networks. What about in countries like Central America? Is there any satellite provider that can be added to AWS or just private networks?
So even in Central America, I think there are already public networks, and one doesn't really need to use a public network. It could be a private network. So especially for all indoor deployments where LoRa is deployed today, it's generally public. It's a private networks, and one can use obviously low power GNSS outdoors. But when the devices are indoors, you can rely on a Wi-Fi, or in the future you will be able to rely on BLE as well to locate your assets. And at the end, there's going to be a video that might be played, or maybe you can log in and actually click on it and see the video, and it will show you exactly how storage device is being tracked in an office, in our office, and then going out to the courier van, and then following all the way up to their department. So there's really no limitation only to the public networks. I'm trying to say it could be running on a public or private networks, LoRa networks. It obviously today LoRa supports roaming, so it could go between multiple networks. And as Karthik said, even if you don't want to use LoRa, you could actually still use the same technology on the cellular IoT network, such as NB-IoT or Cat-M.
Thank you, Roman. And in addition, there are satellite providers in Central America. So I believe EchoStar does have a LoRaWAN satellite network that you can use with an LR1120 based LoRa Edge device that has that LoRa satellite radio with it as well.
Correct, yeah. So for LR1120, the new device, you could definitely use the upcoming satellite providers. This device does not support that, but I think in the future we'll probably see more and more devices on the market that it will interface directly, we'll call it, with the satellite.
Okay, so this next question is related to it. So there needs to be a LoRa network within range. How does this work for mobile assets, trucks, etc., that are in rural locations for animal tracking?
Yeah, so I think I'll answer this question. I already answered probably privately for Andy Bush here, but effectively, if you run out of the LoRa network, let's say there's no coverage, then the devices will store the data, and then they will upload the data, locations, or any other data for that device that measures. Maybe it's environmental, maybe it's actually some stress data, or location. It will be uploaded when the device re-enters the LoRa coverage. Now, it's important to point that in many, especially rural areas, it's much simpler, much simpler and faster to set up a LoRa network than ever expect to get the cellular, like I say, NB-IoT or Cat-M networks, because cellular operators don't deploy those networks in rural areas. So when it comes down to remote areas like oil and gas or mining or agricultural, most customers, or actually most customers of that area, they're actually deploying LoRa networks or some other networks because it's much faster, simpler, and cheaper than expect to get a coverage from the cellular network.
Thank you. The next question, losing baggage at airport transit is the biggest problem faced by travelers these days. Do you have any solution or product? This is a good question. So the LoRa Edge solution, I can say I've actually used it myself with this use case. And it works actually really well because when it's in the baggage facility, it doesn't have a clear view of the sky, so it has Wi-Fi and it's able to find a location. When it's out on the tarmac, it has GNSS and you can see where your bag is. So you can actually get very, very precise location using LoRa Edge and LoRa Cloud. And I've done it using any of the off-the-shelf trackers that are available on the locator site that I talked about before. So this is a very, very good use case to be able to go and solve. Next question, this is for Roman. Is there BLE support for utilizing BLE beacons for indoor location?
Yes, I think the devices that Jack presented to you, both the Stork and Chickadee, our devices, and all of them, they do support BLE. However, currently the AWS platform supports only Wi-Fi, but BLE is coming up as well in the next release. So there will be companies who want to get more precise location inside their buildings. They can deploy just standard BLE beacons that run for 5-10 years on a battery. They're literally less than $15 on average, and you deploy them. You put maybe every 10 meters, and you'll be able to track your assets inside the building, and obviously when they leave the buildings, outside using a low power GNSS. Just to give an idea, many companies also, let's say couriers, these days they have a BLE beacons inside their vans. So when the devices are inside, let's say when a package is delivered inside the van, then it can read the BLE beacon in the van, which is interfaces to their GPS or other system, and we can track. We know that the package actually inside the vehicle and where it is.
Thank you. The next question is also for you, Roman. How often is the Chickadee unit updating?
By default, I mean, it's settable by each customer, obviously, and they can be set by, they can be driven by time, they can be driven by event, because many assets, they move and then they stay stationary for a long period of time. So when they move, you can set them to be updating every 1 minute, every 5 minutes. When they're stationary, you can set them to be updated every 30 minutes or so. If we were to just simply set them on interval, we generally set them every 10 minutes, and they would actually last for minimum 5 years for the Stork, and about 6 months for the Chickadee devices, which are actually rechargeable. But in many cases, many customers will set them differently. They would say, keep updating more regularly when the device is in motion, and obviously don't update very fast or often when the device is stationary, and you can actually get much longer battery life.
Great, thanks, Roman. Another question for you. Is there the concept of LoRa network roaming? So would it work across multiple countries and networks?
Of course. I mean, so people know that probably like in North America, we be using 915 megahertz spectrum, which is kind of full duplex. So anywhere in North America, devices would, between multiple networks, LoRa today supports roaming, like the LoRa standard supports roaming. So there are multiple networks already support roaming. You can roam between, obviously European networks and North American networks. And these devices, they're designed to operate at North American band. And as long as the operators have a roaming agreement between them, which is very simple, in my mind, it's just more about business side, then devices can roam between different networks. When we build devices, our devices actually, same device supports North American, and we'll call it European bands, which is 915 or 868, and they can be just reconfigured, right? So there's no hardware changes required to the devices themselves to support different networks.
Okay, and related to that, can you give some examples of international networks that the devices could roam across?
Oh,
Gaurav, would you like to answer that one in the context of AWS IoT Core for LoRaWAN?
No, Karthik, can you repeat the last part? My voice got cut over.
Yeah. So this question was related to the one we just answered. It said, can you give some examples of international networks that the devices could roam across? I thought maybe this would be a good opportunity to talk about your EveryNet integration.
Yeah. Oh, yeah, absolutely. So from the EveryNet perspective, we just last week at MWC in Las Vegas, we announced a GA for EveryNet that is currently available in US and UK. So through that, the customer doesn't need to deploy any gateways. They can look at the coverage map of EveryNet directly from AWS IoT console, and then based on that coverage, they just need to simply configure or provision the tracker directly on AWS IoT core. There is no need to provision a gateway, and then the device will work directly, and they will be able to see the data. Not just the data, they will be able to see a dot on the map. So because there is a direct integration with the native decoder, there is no need to write any decoder. They can see by just simply provisioning in US and UK, where there is EveryNet coverage, and we are currently working on providing coverage in other countries as well.
Thanks, Gaurav. Okay, here's a good question. With all the networks available, do these work on Amazon Sidewalk? So currently all the devices that we showed are for LoRaWAN. But having said that, there are devices which will work on Sidewalk and LoRaWAN. There's actually a workshop that AWS is hosting at reInvent. I believe the workshop code number is IoT 303. And this will be a workshop specifically on using a LoRa Edge device with Amazon Sidewalk. So I encourage you to check that out. You know, we're certainly making progress in the space, and that'll be the first of many types of devices and applications which can work on Sidewalk as well. Okay, next question is for Pedro Mendoza. Is the saving of the location data until the device can be reconnected to LoRaWAN network a base feature of the LoRa Edge chips?
Yes, thank you, Karthik. Right now, that's not a base feature at the chip or, let's say, stack level, right? But as we have seen, OEMs, manufacturers that build devices on top of LoRa chips, such as TEKTELIC, has really managed to add that value at the firmware level. Probably either Roman or Jack can elaborate a bit more on how TEKTELIC did that. But yeah, that's something, let's say, at the OEM firmware level.
Could you? Oh.
Okay, very good. I think that takes us through all the questions in the list. If anybody wants to ask a question, I'll wait another 20 seconds here. If not, we will conclude the webinar. Okay, so here's a question for Max. Where do the MAC address and SSID information, I presume he's asking about Wi-Fi scanning, are these collected and provided by AWS worldwide?
So you have to configure your devices to do the Wi-Fi scanning, yeah, to collect the MAC address SSI and then parsing to our payload, the JSON payloads to send into device location. Yeah. So mainly customers have to configure the device themselves. Yeah, and if you have challenge and questioning of how to do so using command line, you can reach out to our solution architectures. They would able to providing some supports. Yeah.
All right, very good. Well, I don't see any more questions. There's one more. GNSS only works in US and China? No, actually, these are the satellite systems which are used. So the GNSS system works essentially worldwide, but in China, they have their own satellite system called Beidou. Again, it works all over the world, but it's just two different systems. So these are global positioning systems that will work throughout the world. Okay, very good. It looks like that's the end of the questions, and we are almost at the top of the hour. So I'd like to thank everyone for your time today and attending our webinar. And again, we will make this presentation available offline, and we wish you a good day. Thank you for joining.